Today we're going to be talking about the properties of exponents. And what that means is that we're going to have some expressions that we're going to simplify using these properties of exponents. Kind of like how when we simplify expressions, we make them smaller, like we combine like terms. That's somewhat of the same idea here. And we've done some of these things before, like when we multiplied x and x, the result was x squared. That is a property of exponents. So the names are not as important as being able to use them. So one of the properties says that if I have the same base and I'm multiplying the two things, the base stays the same, but then I add my two exponents. So an example of that might be like x to the third times x to the fourth. That equals x to the seventh. I'm multiplying my two terms, so I add the exponents. The next one is the power property, where you distribute. And what you do then is you multiply the powers, or multiply the exponents. So if I have x to the third raised to the seventh power, that's really going to be x to the 21st power, because 3 times 7 is 21. This property, I have two things being multiplied, a times b, and that product is being raised to the m power. So you distribute this, the exponent. So it's going to be a to the m times b to the m. Now, back a while ago, I said that you could not distribute the exponent in this instance, and the reason for that is because you have a plus. We don't have that in this problem. We have two things being multiplied, so we can distribute the exponent. Like, for example, if I have x and y raised to the fourth power, that's x to the fourth times y to the fourth. Now, the negative exponent property, that tells us that if we have a negative exponent, we can put it on the other side of the fraction bar. You may say, well, there's no fraction bar in this problem. Remember, everything can be written as an invisible over 1. So what this means is that I can take this a to the negative m, and I can write it as 1 over a to the positive m power. So once I move across the fraction line, my exponent changes signs. Nothing else about the problem changes, only the exponent goes from negative to positive. Well, what if we already had a negative exponent in the denominator? What if I had 1 over a to the negative m? Well, again, you're going to move this term to the numerator. You're going to move this to the numerator, and it's going to become a to the positive m power. So whenever you have a negative exponent, you want to move it to the other side of the fraction to get a positive exponent. An example of that, I have x to the negative fourth. That's going to be 1 over x to the fourth. Or if I had 1 over z to the negative third, that's z to the positive third power. So again, negative exponents, to make them positive, you cross the fraction. If there's no fraction there, make one. Put it over 1. One of my favorite properties is the zero property. Anything to the 0 power is 1. Anything, no matter what. The quotient property states that if the base is the same and I'm dividing, I can take my exponents and subtract them, and the result will go in the numerator. So if I have x to the fifth over x squared, I'm going to do 5 minus 2 and get x to the third. And then the last one is kind of like the one up here where we distributed the exponent, but we have a fraction. We're going to distribute the exponent to each of these. That's going to give us a to the n over b to the n. So if I had x over z raised to the third power, that's going to be x to the third over z to the third. So in isolation, these properties are not too terrible to deal with. It's when we do these examples below, when we're combining a bunch of them, that's when things get a little bit tricky. All right, so let's look at these examples down here. We're going to evaluate this. So what that means is we want to get the value of this expression here. So what I like to do first is I like to simplify the inside, meaning are there any like bases? And right now there are no like bases. So then I will distribute this to the inside. So I'm going to get 1 to the negative 8th power. Because I have a power raised to a power, I'm going to multiply. And 3 to the second to the negative 2 will be 3 to the negative 4 power. Okay. Now, because these bases have negative exponents, I can move them to the other side of the fraction bar. Now, you don't always swap places regardless. You only move on the other side of the fraction bar if you have a negative exponent. It just happens in this instance, I have a negative exponent on the top and the bottom. So then this is going to equal 3 to the positive 4th over 1 to the positive 8th. Well, 3 to the 4th is 81, and 1 to the 8th, well, 1 to any power is 1. So we get 81 over 1, which is 81. Example number 2, we have the same basis here. So we're going to have w raised to the 5 plus negative 8 plus 6 power. And I'm just going to write this out once so you can go back and see how do I get that value. So I get y raised to the third power because 5 plus negative 8 plus 6 is positive 3. Then example number 3, I can't simplify anything inside the parentheses, so now I'm going to distribute this negative 2. What that is going to get me is c raised to the negative 2 over d raised to the positive 8 because negative 4 times negative 2 is positive 8. So now I want to make sure all my exponents are positive. This is a negative exponent in the numerator. It goes to the denominator. Our d is already raised to a positive power, the positive 8th power, so I'm not going to do anything with it. I'm going to leave it alone. So it's going to be 1 over c squared times d to the 8th power. And that is my simplified expression. Now, this one, you could do this a couple ways. I like to subtract when I can. Like I don't like to move my exponents from the numerator to the denominator unless I am done with the addition or subtraction. I have a to the negative 3rd over a to the 5th, so I'm going to subtract those exponents. Negative 3 minus 5 is negative 8. So it's going to be a to the negative 8 times b squared. Well, negative 8, I can't have this in the numerator. Remember when I said if you don't see a fraction, you can make it over 1. So now I can take this and put it in the denominator, and it's going to be b squared over a to the 8th power. This one is going to be 7 because I don't have any exponent with the 7. It's an invisible 1. And then y to the 2nd power times negative 4. times y to the negative 4 power because I'm multiplying. I'm multiplying y to the second times y to the negative 4th. I'm going to add my exponents. So 2 plus negative 4 is negative 2. And z to the 5th times z to the negative 1. I'm going to add the exponents to get a positive 4. So I have this that I need to move to the denominator. I'm not going to move anything else. The 7 is going to stay, and the z to the 4th is going to stay. Y squared. This is my simplified answer. All right. Example 6. I have a bunch going on here. So before I distribute that third power on the outside of everything, I'm going to deal with my bases. So a to the second over a to the third. That's going to be a to the negative 1 because 2 minus 3 is negative 1. And then b to the negative 1 divided by b squared to the positive 2 power. 1 minus 2 is negative 3. Over this negative 2 is going to stay there. Now I will raise this to the third power where I distribute this 3 to everything, even this 2 down here. So this is going to give me a to the negative 3rd times b to the negative 9th over negative 2 to the 3rd power. Now I'm going to start moving things across the fraction line. One of the biggest things or problems I will see is students looking at negative 2 to the 3rd power and move that to the numerator because they say, oh, negative 2, that's a negative. You're only looking at the exponents. You only move something if it has a negative exponent. So this negative 2 has a positive 3 exponent, so we're going to leave it alone. I'm going to move these down into the denominator. So I'm left with 1 on the top over negative 2 to the 3rd power is negative 8. And we have a to the positive 3rd times b to the positive 9th. And that is our simplified answer. This one, I'm going to simplify this first. That's going to give me 8 to the 3rd because 5 minus 2 is 3, raised to the negative 1 power. This is going to be 8 to the negative 3rd, which if you put this again over 1, you can see that we can take this and put it downstairs, and we get 1 over 8 to the 3rd. If you type in 8 to the 3rd in your calculator, you'll get 512. So this is 1 over 512. And finally, when we multiply fractions, we multiply straight across. So I'm going to do that first. X times x to the 3rd is going to be x to the 4th. You have y to the negative 1. And then we have that 7 in front over x squared. And then I'm going to do y times y to the negative 4. That's going to give me y to the negative 3. Because remember, when you multiply, your exponents get added. Yes, I know there's a division symbol, a fraction bar in this problem. But my first step that I did was I multiplied the numerators together and the denominators together. Now I'm going to worry about the fraction. So 7 doesn't have a negative exponent. It has that invisible 1 up here. So 7 is going to stay at the top. Then I have x to the 4th over x squared. So take the exponents, 4 minus 2. That gives you 2. And for the y, I have y to the negative 1 over y to the negative 3. If we take our exponents, negative 1 minus negative 3. So 1 minus negative 3, which is the same as 1 plus 3, negative 1 plus 3, that's going to give you positive 2. And this is my simplified answer. So these rules of exponents, like I said, in isolation, if you did just one property by itself, it's not too bad. But when you start combining them, that is when it gets a little more difficult. So hopefully you're able to just look at one thing at a time and work your way through to simplifying it completely. So thanks for watching. Make sure to like and subscribe to the video.